Hello guys, welcome all of you. Today we have to see weinbridge oscillator, its construction and working. So before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So see, this is the circuit diagram for weinbridge oscillator. We all know it is a circuit for all frequencies in the range of 10 Hz to about 1 MHz. It is the most frequently used type of audio oscillator as the output is free from circuit fluctuations and ambient temperature. So it is essentially a two-stage amplifier with RC bridge network. See here, this is two-stage amplifier with this is the RC bridge network, and this RC bridge network we called as feedback network. The bridge circuit, see here, this is our feedback network. The bridge circuit, it is also called as bridge circuit. So this bridge circuit has the arms R1, C1, R3, R2, C2, and this is LP, that is tungsten lamp is used here. So resistances R3 and LP are used to stabilize the amplitude of the output. The transistor T1, this is transistor T1. So this transistor T1 serves as an oscillator and amplifier, while the other transistor T2 serves as an inverter, that is to produce a phase shift of 180 degree. So positive feedback through R1, see here, positive feedback through R1, C1, R2, C2 to T1, we get here positive feedback, and the negative feedback through voltage divider to input of T2. This is voltage divider to T2. So see the working of this weinbridge oscillator. So as we know, in this oscillator the amplifier section will comprise two-stage amplifier formed by the transistors T1 and T2, and output of T2 is fed back as an input of T1. See here, this is output of T2 is fed back via C3 to the input of T1 via this weinbridge network. So see, noise inherent in the circuit will cause change in base current of T1, which will appear at its collector point after being amplified with a phase shift of 180 degree. So this transistor T1 produces phase shift of 180 degree due to inherent noise in the circuit, which will cause the change in base current, means change in current means a phase shift of 180 degree. Then this is fed as an input to T2, fed back to the input of T2 via this capacitor C4 and gets further amplified and appears with an additional phase shift of 180 degree. So T2 further amplified this signal and we get further 180 degree phase shift. So total phase shift is 360 degree. So our phase shift condition, that means positive feedback, is achieved. Positive feedback is achieved. This is our feedback network. So this is construction notes for your reference. This is working for your reference. And the frequency of weinbridge oscillator is, the frequency of oscillation is determined by the series R1C1 and parallel R2C2 of the bridge network. So F is equals to 1 upon 2 pi under root R1C1 R2C2. So this is the important formula for the problem solving of Wein-bridge oscillator. And if R1 equals to R2 equals to R and C1 equals to C2 equals to C, therefore the formula becomes F is equals to 1 upon 2 pi R into C. So see the advantages. It gives constant output. Second, the overall gain is high because of 2 transistors. Third one is the frequency of oscillations can be easily changed by using potentiometer. Then the disadvantages are, the circuit requires 2 transistors and a large number of components. It cannot be generate very high frequencies. So this is all about Wein-bridge oscillator, its working, its construction, its advantages and disadvantages. Thank you.